Indole metabolites may not sound like the rock stars of anti-aging science, but don't let their small size and obscure name fool you. They're molecular powerhouses with a flair for cellular drama. These tiny, aromatic molecules are derived mainly from tryptophan, an amino acid famous for its role in turkey dinners and sleepy post-holiday naps. But in the hidden world of metabolic biochemistry, tryptophan is less about drowsiness and more about transformation. Through the action of gut bacteria, it can be converted into a host of bioactive indoles that enter the bloodstream and, from there, go on to do very big things. Structurally, indoles are like the compact cars of the molecular world, efficient, stable, and surprisingly versatile. The core indole ring, a 6-carbon benzene fused to a 5-membered nitrogen-containing pyrrole, is a motif that nature loves to use again and again. This isn't just biochemical vanity. It's because the indole structure allows for interactions with a broad range of cellular receptors and enzymes. That's part of what gives indole metabolites their regulatory edge. Despite their modest molecular weight, they're master negotiators, influencing inflammation, oxidative stress, mitochondrial function, and even the way your skin holds onto collagen. Let's start with inflammation, the slow-burning fire that underlies nearly every age-related disease. Certain indole derivatives like indole 3, propionic acid, IPA, act like tiny diplomats to calm the immune system. IPA is produced by gut microbes like Clostridium sporogenes, and when it shows up in the bloodstream, it seems to signal, all is well, to immune cells. It activates the aryl hydrocarbon receptor, AHR, a kind of biochemical switch that controls inflammation and detoxification. Activation of AHR by indoles doesn't just reduce inflammation, it also helps maintain the integrity of the gut-blood barrier. That's right, these molecules may be helping to prevent the dreaded leaky gut from triggering systemic chaos. Then there's oxidative stress, the cellular equivalent of rusting from the inside. Indoles, particularly IPA and indole 3, lactic acid, have been shown to act as antioxidants. And not just in a generic vitamin C kind of way. These molecules may directly scavenge free radicals while also upregulating the body's own antioxidant defenses like glutathione and superoxide dismutase. Think of them as the secret agents of redox balance, blending in with the crowd, but keeping chaos in check behind the scenes. But perhaps the most glamorous role of indole metabolites is in the preservation of collagen and skin health. Collagen, as you probably know, is what keeps skin firm, joints smooth, and your face from turning into a slow-motion topographic map. Aging, UV exposure, and inflammation all conspire to break it down. Some emerging research suggests that indoles may help reduce the expression of matrix metalloproteinases, MMPs, the enzymes responsible for collagen degradation. In plain English, indoles might be telling your body to stop chewing up its own scaffolding. And the story doesn't stop at skin-deep benefits. Indole metabolites may also play a role in brain aging. Some can cross the blood-brain barrier and influence neuroinflammation, synaptic function, and even the rate at which new neurons are formed. It's still early days, but the idea that the same molecules born in your gut can travel through your blood and shape your cognitive destiny is, well, kind of poetic. And also kind of gross if you think too hard about microbial metabolism during dinner. So, what determines how many of these indole metabolites you have circulating in your blood? Mostly your diet, your microbiome, and your metabolic health. Diets rich in tryptophan, found in eggs, seeds, tofu, turkey, and dairy, plus a fiber-rich environment that supports microbial diversity, seem to be the winning combo. Antibiotics, stress, processed food, and poor sleep, on the other hand, tend to crash the indole party. In the end, your bloodstream becomes a kind of molecular mood ring for your lifestyle choices, and indole levels may reflect whether you're aging with grace or with gasoline. Future directions are tantalizing. Could we one day get a blood test to measure key indoles and predict our biological age more accurately than a calendar or a mirror? Could we supplement with targeted probiotics or engineered postbiotics that churn out anti-aging indoles on demand? Could topical skincare products tap into indole chemistry to preserve collagen or reduce age spots? These ideas are still speculative, but they're gaining traction. After all, when small molecules consistently influence big systems, from skin elasticity to immune tone to brain fog, they deserve more than a passing mention in textbooks. So the next time you're thinking about what really makes you age, Beyond birthdays and bad habits, consider the elegant little indoles, drifting through your bloodstream with quiet efficiency. They may not make headlines like telomeres or NAD+, but they're there, putting out fires, patching leaks, and maybe, just maybe, pressing pause on your internal clock.